What is the electric field line? What is electric field? Why it has been introduced? We know that from our knowledge, from our experiment, that two positive charges repel each other. To show this repulsion, there must be some technique so that we can visualize the repulsion or attraction if one is positive and another is negative. So, to make the study of electric field convenient, forces between the two charges convenient, we have introduced the concept of electric field lines. A positive charge having electric field lines outward, radially outward, radially outward, and around a negative charge, the electric field lines are radially inward, and these lines are coming from infinity, and these electric field lines are going radially outward to infinity. And when two charges, positively charged particles, interact at that time, the length of the length of these electric field lines increases. I mean to say that it elongated, means the line which is coming out of this charge straight, and the line which is coming out straight, it will bend, and you can say it elongates like this. The repulsion is shown like this. The repulsion is shown. We know that when there is a source charge, here suppose this is a source charge capital Q at a distance r, here I want to find out the electric field intensity, electric field or electric field intensity, or the strength of electric field, here all the same terms. For this, at point P, mathematical expression, we know that here electric field will be E is equal to K, electrostatic force constant, source charge divided by distance r square. This is the electric field. We can see from mathematics that E directly proportional to, electric field is inversely proportional to the square of the distance between the two charges. Here is the test charge, and here is source charge. From the formula we can see electric field is independent of the test charge, and this mathematical concept we already know, and how this mathematical formula is compatible with the magnetic field lines, that I am going to explain you. Suppose here is the charge, and it is a positively charged particle, then definitely magnetic field lines will be radially outward like this, radially outward, radially outward. These will be radially outward, radially outward. This can be produced to infinity because they go to the infinity. As we go away from this source charge, electric field is changing according to this formula or not. For this, let me do something, whether this formula is compatible with this magnetic field lines or not. I am going to draw here, suppose here area I have selected, and at this point I have selected this area. Obviously this is a circle, and this area is at r1 distance from the source charge, and this area is at r2 distance from the source charge. Then what we notice, number of magnetic field lines passing through these areas. If you remember from class 11th, there was a solid angle we defined. How we defined the solid angle? Solid angle was defined by d omega, and it was is equal to this area upon r square. If you can connect from here, this is delta a, this is distance r from the source, and here this is the solid angle, we can say this is the solid angle. This is what? This is d omega. From here we can represent area, delta a in terms of this radius and this d omega, which is a solid angle. So obviously this will be the product of area will be the product of the square of the radius and the solid angle. Here I am writing dE, this area I want to find out. Obviously it will be d omega multiplied by r1 square. Similarly, this area will be dA is equal to, obviously it will be dA dash, and it will be d omega. Angle is solid angle is same for both, only the square of the radius is going to change. And suppose there is n number of magnetic field lines passing through these areas, and we know that electric field depends upon number density of electric field lines. Suppose n number of magnetic field lines passing through both the areas, what we can say here, the density will be n divided by area d omega r1 square. This is the number density through this area, and through this area the number density will be n divided by d omega r2 square. This you keep in your mind. And we know electric field at this plane we can say E1, and at this plane it is E2. The electric field E1 upon E2, we can say that directly proportional to n upon d omega r1 square divided by this n and this d omega r1 square. From here we see that this n cancel, this d omega cancel, E1 upon E2 is equal to, I have done a mistake here a little, this will be R2, it will go here, like r2 square upon r1 square. I can put here a constant because I have removed this proportionality sign. So from here what we see this is E directly proportional to 1 upon r square. So this is magnetic field lines absolutely compatible with the mathematical forms. Thank you very much.